Hello there and welcome. Now let's look at this Form 3 paper and let's begin from question number 1. So there are only few questions in this paper, so let's see. So as you can see, you are being told, the first question you are being told, the data given below was recorded when metal M was completely burnt in air. Then you are being told that M is not the actual symbol of this metal. So after that, as you can see, we have been given the relative atomic mass of metal M. So the relative atomic mass of metal M we have been told is 56, and then for the oxygen we have been told is 16. So the other thing you should note about this question is that M is not the actual symbol. So they're just using M as an arbitrary letter to represent an element which is found in the periodic table. So the next information given in the question, as you can see, we have been told that the mass of the empty crucible plus the lid is 10.24 grams. So that is now the empty crucible plus the lid. So if we add them together, the next info given, we are being told that the mass of the crucible plus the lid plus the metal M is 10.352 grams. So remember this now, the crucible lid plus now metal M is 10.352 grams. And then finally I've been told that the mass of crucible, lid, and now metal oxide. So for this metal oxide is now this metal M which has now reacted with oxygen. So the mass of crucible, lid, and metal oxide we have been told is 10.40 grams. So the first question therefore is asking, determine the mass of metal M. So how are you going to get now the mass of metal M only? So we only take now metal M and find its mass. So how are we going to get the mass now of metal labeled M? So first, to get the mass of metal M, we have to take into consideration the three information that you have been told about the mass of this and mass of that. So first, to get the mass of metal M, what you should do, so first of all, you should take the mass of the crucible, the lid, and metal M, so that is 10.352 grams. So you take that first mass, then you subtract now with the mass of the crucible and the empty crucible and the lid only. So if you do that, you are going to say 10.352, then subtracting from 10.24. So if you do this, you are only going now to get the mass of the metal M only minus now the crucible. So if we subtract it correctly, so we're going to get the mass is 0.112 grams. And that is now the mass of now this metal M. So in Roman 2, we have been told to find the mass, determine the mass of oxygen. Remember, it's not oxygen gas. The question is specific. They only want us to get the mass of oxygen and not oxygen gas. So how do we get the mass of oxygen? Again, we take these three information that you are given about the masses of the crucible, this and that. So for us to get the mass of oxygen, so we are going to take the mass of the crucible, the mass of the lid, and the mass of the metal oxide. So we're going to take the last information, the third information is what you're going to take. So the mass of the crucible, the mass of the lid, and the mass of now the metal oxide. So this metal oxide, remember, it is metal M which has now reacted with oxygen. So that's why we consider this, plus the metal oxide. Then after that, we are also now going to subtract it from the mass of the crucible, lid, and the metal, so that we only seclude oxygen from the metal oxide, and the metal, we only get the mass of oxygen. So in this case, therefore, what you are going to do, we are going to say 10.40, then we subtract from 10.352, as you can see we have done here. So 10.40, then we subtract from 10.352, then you're going to get the mass of oxygen. So as you can see, the mass of oxygen is 0.048 grams. So that is now the mass of oxygen that we get. So remember, we have the mass of metal M, which is 0.112 grams. Then after that, therefore, we have the mass of now the oxygen, which is 0.048 gram. So like automatically, if you have been revising chemistry, so you should know that anytime you'll be asked to calculate such masses, obviously there might be a question on moles, or there might be a question on molecular formula, or there might be a question on empirical formula. So now that you have calculated this mass, so the next question that you are going to see, it's empirical formula. So the question B, it's asking, determine the empirical formula of the metal oxide. So what is the empirical formula of the metal oxide? So remember, empirical formula is the simplest formula of a compound. So that is the simple definition of empirical formula. So in this case, we are being asked, this metal M reacting with oxygen, what was the formula? Is it written as M3O? Is it written as M4O? Is it written as MO? So that is what the question is asking. We determine the formula of now this oxide. So remember, we are going to use this information that we have. The first information that we have, remember, we have calculated the mass in the previous question. Apart from that, remember, as we are reading the question, we were given the relative atomic masses. For metal M, remember, we are told was 56. For oxygen, remember, we are told is 16. So using these masses, now we can be able to calculate the empirical formula of this compound between metal M and oxygen. So as you can see, this is the table of empirical formula. So you can see we always begin with the element on the top. So in this case, in our case now, we are dealing with elements. In some empirical formula, you may deal with compounds. But in this question specifically, we are dealing with now elements. So as you can see, the first element we have written is metal M. Then the second element that we have is oxygen. So remember, in this question, we are not dealing with the oxygen molecule. We are dealing with oxygen atom. Again, it's not oxygen gas, but we are only dealing with oxygen. So that's why we only consider one atom of oxygen. So for the empirical formula, the next step after now the elements, it is always the mass. So it is always, we write the masses that you have been given. So remember, we calculated the mass of metal M and found out that the mass of metal M was 0.112 grams. So that is the mass that you're going to use here, 0.112 grams. After that, we calculated the mass of oxygen and we found that the mass of oxygen was 0.048 grams. So that is always the first step in empirical formula, apart from writing the elements. And never forget, that is always the first step. So after writing the elements, always write the masses that you have been given. Remember, it is not the relative atomic mass. It is not the relative molecular mass. It is not the relative formula mass. So here, what you write is the mass that you have been given. So the question will give you these masses, or just like the previous question, you'll be asked to calculate the masses. So that's why now you write this mass that you have calculated. So now after writing this mass, so we go to the next step in empirical formula. So the next step, we are going to write now the relative atomic mass that you have been provided. So remember, for the metal M, we are told that the relative atomic mass of this element was 56 grams. Then apart from that, we are also told the relative atomic mass of oxygen, we are told is 16 grams. So now that you have the relative atomic mass of oxygen and also the relative atomic mass of metal M, now we go to the next step in empirical formula, which is now calculating the moles. We calculate now the moles of these elements that we have. So remember, in the topic of moles, what we discussed. So the first formula that we ever encountered when discussing moles, or after we entered the topic of moles, the first formula that we encountered, remember, it was the formula saying that moles is equals to mass divided by the relative atomic mass. Or if you've been given a compound, you can say moles is equal to the mass divided by relative molecular mass, or the relative formula mass. That was the first formula that you encountered when calculating moles. Now, in this case here, in this empirical formula, that is the formula we are going to use here in order to determine the moles of these elements. Like for instance, you see, for metal M, what we have done, we have said the mass divided by the relative atomic mass, as you can see. So the mass of metal M, it was 0.112 grams. The relative atomic mass of metal M, remember, we have calculated and we have been given to be 56. So here, to get now the moles of metal M, we just apply the formula. It's just that formula. So what you're going to do, you're going to say 0.112 grams divided by 56 grams. So if you do that, you're going to get the moles. So as you can see, the moles we got was 0.002 moles. So that was the moles of the metal M that had combined with oxygen. But let's continue and see. So the next step now, we have to calculate the moles of oxygen. So how do you calculate the moles of oxygen? So to find out the moles of oxygen, what you are going to do, we are going to do exactly the same thing. Remember, the formula is moles is equals to mass divided by the relative atomic mass. So in this case, the moles of oxygen that we have gotten to be 0.048 grams. That was the mass, sorry, not the moles, the mass was 0.048 grams. So apart from that, we now divide this mass divided now by the relative atomic mass that we are provided. So in this case, what we are going to have, we are going to say 0.048 grams divided by 16 grams. That is now the mass divided by the relative atomic mass to give us the moles. So here what you are going to get, as 0.03 as the moles of oxygen. So remember, the moles of metal M that you have just obtained, we have found that the moles of oxygen of metal M is 0.02. The moles of oxygen after calculating, remember, tumepata ni 0.003 moles. So as you can see, those are the moles that you have gotten. Now the next step is now to calculate the mole ratio. So we are going to use these moles that you have just obtained to calculate the mole ratio. So as you can see, the first mole is 0.02 and the second mole is 0.003 rather, 0.002, and the other one is 0.003. So the first step of calculating mole ratio in this case, we are going to divide all the moles with the least moles possible. Again, I repeat, first to get that ratio, so what we are going to do, we are going to divide these moles with the least amount of moles. In this case, we have the moles of metal M and the moles of oxygen. So in this case, if we look at it, it is metal M which has the least number of moles. So that is always that step. In this mole ratio, always divide everything with the least number of moles. So in this case, the least number of moles that we can see that we have 0.002. That is the least number of moles possible in this case. So we are going to divide everything by 0.002 in this case. So if we divide everything by 0.002, on the side of metal M, we're going to get 1. On the side of oxygen, we're going to get 1.5. So that is the mole ratio in this case. So for metal M, the mole ratio is 1. For the next one, which is oxygen, the mole ratio is 1.5. So the other thing we should remember is that the mole ratio should always be in whole number, rounded off to the nearest whole number. So here, since we have 1 and we have 1.5, so the value is at 5. So remember, if the value is at 5, you should never round off. But if the value was 6, so we could round it off. If the value was 7, 8, 9, we could round it off. If the value was 4, 3, 2, 1, we could round it off. But now, since the value is 5, is 1.5. I'm looking at oxygen, that is what I mean. For metal M, iko sawa. That is only 1.0. Hiyo iko sawa. But now, we are looking at now oxygen, because we should convert the mole ratio to a whole number. So for this oxygen, since we have a 5, it is 1.5, we don't round off. What we do in this case, we are going to multiply everything by 2. So as how you can see, we said the mole ratio of metal M was 1 times 2, and then also for oxygen, 1 times 2. So that you should always go through this step if you have a 5 somewhere. If you have 5, remember, don't round it off, but multiply everything with 2. As you can see what you have done. So after multiplying with 2, you can see the mole ratio. We have now 2 and 3. 2 for metal M and 3 for oxygen. Now to complete our empirical formula, you can see below metal M we have 2, and below oxygen we have 3. So it means that it is we had 2 metal M that combined with 3 oxygen. So that is what happened. We had 2 metal M that combined with 3 oxygen. So the question was asking, determine the empirical formula. So the final answer therefore is that empirical formula is M2O. It is M2 and then O3. That is the empirical formula, and that is how simple it is to calculate the empirical formula. Yes, sir. So now let's go to the next question, which is question number 2 according to my case. So question number 2 is asking, the grid provided below represents the part of the periodic table. Study it and answer the question that follow. So as you can see, this grid, this is a periodic table. It's a sample of periodic table. Of course, these letters are not the actual letters. They have just again used arbitrary letters in order to derive a point that now the student should be able to calculate. So now we are being told that the grid provided below represents part of the periodic table. Study it and answer the questions that follow. So as you can see the periodic table, in the first group we have metal M and metal R. Then in period 2 we have M, N, P, T and Z. So question 1 is asking, select the letter that represents an element that loses electrons most readily. So remember the term is loses electrons most readily. Give a reason for your answer. So here the element that readily loses electron is element letter R. So it is letter R. So why is it letter R? So it is letter R because we can see that this letter has the largest atomic radius. So since it has the largest atomic radius and it is a metal, therefore it is easier for this metal R to lose electrons, because the outermost energy level is very far from the nucleus, and also the outermost electron is very far from the nucleus. Therefore, the nuclear force of attraction holding this outermost electron, the nuclear force of attraction is very weak. So now since the nuclear force of attraction holding this electron is very weak, now this electron is readily and easily lost into the environment or to other elements for letter R to be stable. So that is the reason why. So in short, you can say it is letter R. Why? Because letter R has the largest atomic radius with very low nuclear force of attraction. That is it. So this nuclear force of attraction in INI, we did it in the previous classes. So you can just check the previous classes regarding the periodic table. We covered this as a whole. So it is letter R. And mind you, we know letter R is potassium. So the question doesn't know potassium. So in such a scenario, never replace letter R with potassium. So don't say it is potassium, then you go and give reasons. You're going to get it wrong. Kwa sababu, the question does not recognize potassium. The question recognizes M, the question recognizes R, the question recognizes the letters. So don't you substitute it with now the actual element. You're going to get it wrong. So only use the letters that you have been given in the periodic table. So we go to question next. So question next is asking, explain why the atomic radius of P is found to be smaller than that of N. So why is it that the atomic radius of P is smaller than that of letter N? So but you can see letter N has fewer electrons than letter P. So for the letter N, we can see that it has how many electrons? It has 6 electrons, while letter P has 7 electrons. So, but we are being told that the atomic radius of letter P is smaller, but the atomic radius of letter N is larger. So such a scenario, we discussed it in the topic of structure and bonding. The subtopic of trends and properties across period 3 elements. So that is now where we can get this question, just that now the question is asking on period 2. But now the topic that discussed this question at hand was now the topic of structure and bonding. Subtopic was trends and properties across period 3 elements. So now, the reason why letter N has a larger atomic radius than letter P, which has a smaller atomic radius, is because, so like as we move across the period, first thing that happens is that there's the increase in the number of electrons. Now that means that letter N has fewer electrons, letter P has more electrons. So again, I repeat, as we move across the period, there's the increase in the number of electrons. That is the first thing. So as the number of electrons increases, the nucleus force of attraction also increases. So shike hizo vitu mbili. So the first thing is across the period, as we move from now, is it left to right? So as we move across the period, there's the increase in the number of electrons. That is the first step. The second step is, as electrons increase across the period, nuclear force of attraction also increases. So this means that letter N has a lower nuclear force of attraction than letter P. Letter P, therefore, has more nuclear force of attraction compared to letter N. So now, as this happens, so the more nuclear force of attraction, the more the outermost electrons will be pulled in strongly towards the nucleus. So picture ni kama magnet. So you have a strong magnet, you have a weaker magnet, and a magnetic material. So obvious, the stronger magnet is going to pull the magnetic material strongly to its center, but the weak magnet is going to pull these magnetic materials less strongly. So that is exactly what we mean by nuclear force of attraction. It means that letter N, in terms of magnet, just comparison so that you understand. So it means that letter N is a weak magnet, but letter P is a strong magnet. So in terms of pulling electrons, letter N slightly pulls the electrons towards the nucleus, while letter P, since it has very high nuclear force of attraction, it pulls electrons strongly towards the nucleus. Therefore, as this happens, we can now see that the size of letter P will be smaller than the size of letter N. And that answers our question. The question, remember, is asking, explain why the atomic radius of P is found to be smaller than that of letter N. So the reason we'll say that P has a higher nuclear force of attraction than N. So that is the first thing. P has a higher nuclear force of attraction than N. This is because P has more electrons in the outermost energy level as compared to letter N. Therefore, the electrons of P are pulled in more strongly towards the nucleus, therefore making the size of the atom to be smaller than that of letter N. So that is exactly what happens. That is how you're going to answer this question. Why is it that letter P has a smaller atomic radius than letter N? So two things you should understand and never forget is that as we move across the period, there is the increase in the number of electrons. As electrons increase across the period, there is an increase also in the nuclear force of attraction. Now the third thing, as the nuclear force of attraction increases, the size of the atom decreases. So if you can be able to understand this point like that, now you are good to go. It makes it even easier now to go to that topic of trends and properties across period 3, and now you are going to get utapata utakuwa firi. So letter C is asking which two elements it's asking which two elements form ionic bond. So as you can see, these are the elements that we have been given. But again, remember what we said. So even if you know that letter M is lithium, is it lithium? Yeah. Even if you know letter M is lithium, even if you know letter R is potassium, even if you know letter Z is fluorine, don't you substitute these letters with the actual symbol. Because as you can look at this periodic table, as you can look at this question, the question does not recognize letter M as lithium. It does not recognize letter Z as fluorine. It does not recognize letter R to be potassium. The question recognizes there is something called letter M, letter R, letter N, letter this and that. So just to be on the safe side, don't you substitute these letters with the actual elements, just to be on the safe side. So which two elements form ionic bond? So the elements in this case that form ionic bond, we have, for instance, we have letter M and Z, as you can see in the periodic table. So we have letter M and Z. Apart from that, we can also have letter R, and we can have also letter R and Z. Also, we can have R and T. Yeah, also R and T can be able to give us the same. We can be able also to have letter M and letter T, letter M and letter, I think letter P also. Yeah, it can also give us ionic bond. But what is ionic bond? So just to remind ourselves, though it tulishapitia in the previous class. So just to remind ourselves what is ionic bond. So remember, ionic bond, we went through it in the topic of structure and bonding. And for the ionic bond, remember we said that this is a bond formed when metals react with non-metals. That is what we said ionic bond is. So it is a bond formed when metals will react with non-metals. So if you can be able to say that, then you're good to go, because that is just simply ionic bond. So remember the different types of bond we went through in the previous lessons. You can check them out. So we went through covalent bond, which was a bond formed between non-metals. Apart from that, we went through coordinate or dative bond, which is a special type of covalent bond. So remember, that's how it began. Coordinate bond or dative bond, it is a special type of covalent bond whereby one atom donates 2 or more electrons to be shared. So that is what we said about dative bond. Apart from that, we went through molecular bond, metallic bond, hydrogen bond, etc. So you can briefly review the previous lessons that you have just done to go through this topic of structure and bonding, then you're good to go. So now let's go to question number 3. So this question number 3 is asking, distinguish between empirical and molecular formula. So distinguish between empirical and molecular formula. So we had briefly discussed empirical formula kiasi, but now this question is asking on the definition of empirical formula. So now, what is empirical formula? So you can see, empirical formula is the whole number ratio which an atom combines to form a compound. So the whole number ratio which an element or an atom combines to form a compound. So you can be able to remember this table of empirical formula. Remember the first, the mole ratio, the first mole ratio that we found before multiplying by 2. The first mole ratio that we found the mole ratio to have a decimal. Okay, we had 1, and then on the other side we had 1.5. So that was a decimal. But now you see, empirical formula must be a whole number. So that's why to make it whole number, we multiplied everything by 2 in order to make it whole number. So that gives us the definition of empirical formula, which is the whole number ratio. It's a formula which shows us the whole number ratio, like for atoms to combine in order to form a compound. So it must be a whole number ratio. So like, what about molecular formula? So molecular formula is just the formula that defines now the actual number of atoms or elements in a compound. So it defines now the actual number. So for letter M, how many letter M are there? How many oxygens are there? So that is the mole ratio. It's the formula that determines now the actual number of elements or atoms which are now found in the compound. So as you can also see, this table, but this table, the answer we gave was empirical formula. Maybe if you get another question of molecular formula, we are going to go through it and see what happens. So let's continue to the next number now. Wait up. So we are now in number, is it number 4? Yeah, we are now in number 4. So number 4 is asking, the setup shown below was used to investigate a property of hydrogen gas. So the setup below was used to determine the property of hydrogen gas, as you can see. So we have the glass cover, we have the porous bag, we have air, then we have beaker A. So where that circle inapatikana, that is beaker A, then we have glass tube original level, and then we have beaker labeled B. So the question is asking, state and explain the observations that will be made in the glass tube if beaker A was filled with hydrogen gas. So what will happen if beaker A, now the surrounding of beaker A, what will happen if this beaker A will be filled with hydrogen gas? So remember, here we have been given a porous bag. Porous means what? So porous means it has holes, very many holes. The best example to explain porous will be a sponge. You see how a sponge has very many holes. So a sponge is porous. Why? Because a sponge has very many holes. So that is what is meant by the term porous. Kitu iko na mashimo mingi tudogo. So for this bag, we are being told that this bag is a porous bag. So that is a porous bag. Then apart from that, we are being told that the surrounding environment contains hydrogen. So state and explain the observations that will be made in the glass tube if beaker A was filled with hydrogen gas. So the hydrogen gas is going to diffuse through the porous bag. So after diffusing through the porous bag, the hydrogen is going to move through the delivery tube like that. So apart from moving through the delivery tube, on the side of beaker B, we are going to now see small bubbles of hydrogen now getting expelled from the delivery tube. And that is all the observation that the question was asking. Nothing else, because you have the original level of water, glass tube, etc. So remember, the first thing that is going to happen is that hydrogen is going to diffuse through the porous bag. And then after diffusing through the porous bag, hydrogen will move through the delivery tube, and it will be seen on the other beaker B to be the hydrogen will be escaping the delivery tube into the original level of what into the water, and it will be seen as bubbles slowly by slowly rising through the water. So that is exactly what you are supposed to say in this case, and then you'll be good to go. So it was that simple to get those marks. So the next question is asking state Charles' law. So what does Charles' law state? So state Charles' law. So simply Charles' law states that for a fixed mass of gas, the volume of air is directly proportional to the absolute temperature when the pressure is kept constant. That is Charles' law. Again, it states that the volume of a fixed mass of gas is directly proportional to the absolute temperature when pressure is kept constant. Also, we discussed these gas laws in the previous lesson. You can go and check them. But just to remind ourselves, remember we had three major laws, in fact 4 major laws that we looked at. So just to go through Boyle's law definition, we can say that Boyle's law states that for a fixed mass of gas, the volume of that gas will be inversely proportional to the pressure when the temperature is kept constant. So that was Boyle's law. Now the other law we looked at was Graham's law of diffusion, which states that the rate of diffusion of any gas is inversely proportional to the square root of it's inversely proportional to the square root of its density when pressure and temperature are kept constant. Now the other law that we looked at was combined gas law. For this combined gas law, just from the word combined, now this law combines Boyle's law to the top and Charles' law going to the bottom. That's why it is called a combined gas law. So for this combined gas law, again, remember, if you can check the formula, on the top side we have a replica of Boyle's law. On the lower side we have a replica of Charles' law. Just that we have temperature. Now that's why we are saying it is Charles' law. So that's why it is called combined gas law. So apart from that, question number B is asking, a certain mass of gas occupies 146 decimeter cubed at 20 degrees Celsius and 98.31 pascals. Then the question is saying, what will be its temperature if its volume is reduced to 133 dm cubed at 11.325 pascals? So for this question, you see, part A of the question was asking Charles' law. Now, part B of the question is asking something different. Here we can't apply Charles' law in this part B. So a student who is not careful is just going to apply Charles' law here, but you're going to get it wrong. Because the reason why we are not dealing with Charles' law in this case is because, as you can see the question, we have been given volume 1, which is 146 dm cubed. Temperature 1 we have been given as 20 degrees Celsius. and pressure 1 we have been given as 98.31 pascals. So remember, we have these three variables that have appeared in this case. So the next part of the question, we are being told what will be its temperature if its volume is reduced to V2 133 dm cubed, and then P2 we have 101.325 pascals. Then we are being told to find the temperature. So in this case, you can't apply only Boyle's law, you can't apply only Charles' law, you must apply combined gas equation, or it's called an ideal gas equation in this case. So for the ideal gas equation, remember it is P1 V1 over T1 is equals to P2 V2 over T2. That is pressure 1 times volume 1 over temperature 1 is equals to pressure 2 volume 2 over temperature 2. So that is what you're going to apply here in order to get the correct answer. So the next thing that you should do in this case, you should convert every degree Celsius to Kelvin. That is what you should do before even begin calculation. So never calculate gas laws with temperature being degrees Celsius. Utapata wrong ingine healthy. Get a very healthy wrong. So all degrees Celsius must be converted to Kelvin, and then you make the calculation. So now, for instance, here we are being given 20 degrees Celsius. So how do you convert 20 degrees Celsius to Kelvin? What do you do? So you take this 20 degrees Celsius, then you add 273. So if you take 20 plus 273, you're going to get 293 Kelvin. So this is what you are going to use for temperature. So always convert degrees Celsius to Kelvin before calculating in all gas law. So the pressure 1 is 98.31 pascals, volume 1 is 146 dm cubed, and then temperature 1 is now 293 Kelvin. Then is equal to, now everything, we are going to take now the 2 side. So we're going to take P2 to be 98. Pressure 2 is going to be 11.325 pascals. Then the volume 2 is going to be, volume 2 have been given us 133 dm cubed, and then we are now going to find the temperature 2. So if you make all your calculations correct, that is the answer that you are supposed to get. So again, remember, if you have been given all these three variables are interchanging, you should never use either Charles' law, or you should never either use the other law, which is the Boyle's law. If all these three variables are changing, what you should do, you should use the combined or the ideal gas equation. Like for this case, you see everything is changing, we have used the ideal gas equation. So if you do that, you are going to get the temperature 2 in Kelvin. So if you get the temperature 2 in Kelvin, you are good to go. But what if the answer has asked us to get the temperature in degrees Celsius? So if it has asked us to get the answer in degrees Celsius, you just subtract minus 273 and then you get the degrees Celsius. Then you're good to go. So concerning this gas law, remember we had checked them in the previous classes. You can just go and review the different gas laws that we went through by. So we go to the next number, which is number 6. So the question is asking, 140 centimeters cubed of nitrogen gas diffuses through a membrane in 70 seconds. How long will it take 200 centimeters cubed of carbon 4 oxide to diffuse through the same membrane under the same conditions of temperature and pressure? So remember, we have been told that the temperature and pressure are constant. So which law focuses on temperature and pressure being constant? It's the Graham's law of diffusion, which states that the rate of diffusion is inversely proportional to the square root of its density when the pressure and temperature are maintained constant. Now, since you have been told that the temperature and pressure are constant, therefore the law we are going to use here is Graham's law of diffusion. So we have been told that nitrogen is 14, carbon is 12, of course, and oxygen is 16 grams. So now, what we have been asked to compare with is carbon 4 oxide. So we are comparing this nitrogen with carbon 4 oxide. So for the carbon 4 oxide, you have been told it is 200 centimeters cubed. But the nitrogen we have been given nitrogen is 140 centimeters cubed. So what do you do in this case? So the safest thing to do in this case inakwanga, so bring this nitrogen gas, the volume, to the same volume of what you have been asked for carbon dioxide. So make the volumes to look similar or to be similar before applying the Graham's formula. So this is what I mean. So what you have been asked carbon dioxide, which is 200 centimeters cubed. So we are comparing in nitrogen na carbon dioxide, which is 200 centimeters cubed. So this nitrogen that we should now be calculating, we have only been given it is 140 centimeters cubed. So here what you're going to do, we are going to assume this nitrogen gas, the volume of nitrogen, let's bring it to match the carbon dioxide through calculations. So this is what you're going to do. You're going to say, if 140 centimeters cubed of nitrogen gas takes 70 seconds, J200 itachukua ngapi? So if 140 centimeters cubed of nitrogen gas takes 40 seconds, what about 200 centimeters cubed of nitrogen gas? Remember, bado, like we are not concerned with carbon dioxide. We are still dealing with nitrogen, bringing the volume of nitrogen to match for carbon dioxide so that we do the calculations. So if 140 centimeters cubed of nitrogen gas takes 70 seconds, what about 200 centimeters cubed of nitrogen gas? How long will it take? So if you will make your calculations, you're going to get that 200 centimeters cubed of nitrogen gas is going to take 100 seconds. That is what is going to happen. So 200 centimeters cubed of nitrogen will only take 100 seconds. So now, since the volume are exactly similar, volume of nitrogen, volume of the carbon dioxide, so the volume is similar, now we can be able to compare. So the next step, the next thing that we should do, we should find the relative molecular mass or the masses of these elements. So for the nitrogen, we have nitrogen gas, which is N2. So we're going to say 14 times 2, we're going to get 28 grams. So nitrogen is 28 grams. For carbon dioxide, we have carbon and 2 oxygen. So if you add the relative molecular mass, you're going to get that it is 44 grams. So now after that, we are now going to apply the formula of Graham. So in this case, remember, what are we comparing? We are comparing time and we are comparing the masses. Now in Graham's law of diffusion, this is what you should never forget. If we are dealing with time, everything is directly proportional. Again, remember, if you are dealing with time, everything is directly proportional. That's why we said the time of gas A over the time of gas B is equal to the square root of the molecular mass of gas A over the square root of molecular mass of gas B. Directly proportional, I mean, if it is A numerator, it is A numerator on the other side. If it is B the denominator, B the denominator on the other side. So this only and only applies when you are calculating time. But if you're calculating mass and density, if you're calculating what and what, is directly proportional. But if you're calculating anything regarding time, so the formula is always directly proportional. So don't you forget that. So step 3 now, to apply the formula. So we are going to say 100 seconds divided by the time of B. Remember, B is what we don't know. We are calculating now the time of carbon dioxide. So 100 seconds divided by the time of B is equal to the square root of 28, whereby 28 is now the mass of nitrogen gas. Remember, 100 seconds is for nitrogen, and then on the other side, the square root of 28 is nitrogen. So 100 seconds divided by the time of B is equal to 28 grams divided by 44 grams. So that is exactly what now we are going to do in this case. So if you calculate it correctly, so you are going to get that the time of B is 125.36 seconds, as you can see. So it is 125.36 seconds. So that means that that is the time carbon dioxide is going to take to diffuse through that medium that you have been told. So like, if you can see, the time of nitrogen is less, but the time of carbon dioxide is more. So this means that nitrogen gas is a very light gas. That's why it diffuses very fast. While carbon dioxide is a denser gas. That's why it diffuses slowly. Nitrogen only takes 100 seconds. Carbon dioxide, the heavier gas, takes 125 seconds. So that proves that we are correct as per our calculation. So the answer was that 125.36 seconds. So we go to question number 7. Is asking, the graph below shows the relationship between pressure and the temperature of gas in a fixed volume of container. Then you have been told, state the relationship between the pressure and the temperature from the graph. This is simple. This is just, you just check the Cartesian plane. On the x-axis, what do we have? We have temperature. On the y-axis, what do we have? We have pressure. This is the simplest marks you can ever get in chemistry. So here what happens, simply we just talk about what that diagonal line that has been drawn. So you can say, as the pressure increases, or rather we can begin with temperature. Either can do. As the temperature increases, the pressure also increases. And that is that simple. So the temperature is increasing according to this graph. So the pressure also increases just the same way. So the question is that simple. That is all you should say in this case, and then you're good to go. So question B is asking, using kinetic theory, explain the relationship shown in the graph. So using kinetic theory, explain the relationship shown in the graph. So you can see that as the temperature increases, also the kinetic energy of these gas particles are going to increase. So the kinetic energy, the movement of gas particles, is also going to increase. So as the movement of these particles, that is kinetic energy. As the kinetic energy of these particles increases, so there will be collision. These particles will be colliding against each other. So there will be collision between these particles. As these particles collide against each other, so this collision is going to lead to now the increase in pressure of that gas or that container. That is it. So remember, the main point here is temperature increases. As the temperature increases, movement of particles also increases. So as the movement of particles increases, the collision, the bombardment of the particles is also going to increase. So the particles are colliding against each other. This is also now going to increase now the pressure of that gas. And it is that simple. So if you can be able to get them in that point form, then you are just good to go. So we go to the next number, which is number 8. We have been told, convert the following temperature into absolute scale. Absolute scale, they mean you convert it to Kelvin. That is what they mean in this case. So convert the following temperature into absolute scale. So the first one was 25 degrees Celsius. So how will you convert 25 degrees Celsius to absolute scale? So you are just going to add to 73. Simple, just like that. So you just punch these numbers in the calculator and you have your marks. So 25 plus 273, you're going to get 298 Kelvin. That is one. Roman 2, you have been asked 127 degrees Celsius. So you're still going to say the same thing. 127 degrees Celsius plus 273. So you're going to get 400 Kelvin. So after doing that, then you are good to go. So that is 400 Kelvin. So the next number, which is number 9. So number 9 is asking, the diagram below shows chromatograms of 5 different dyes, as you can see. So we have this chromatogram, we have the 5 different dyes in this chromatogram, which is A, B, C, D, and E. So name this technique that is used in this case. So the technique, of course, this method of separation is called what? Chromatography. That is what they want you to answer. So name this technique used in separating colors. So this technique is called chromatography. So the next question is asking, what is meant by the term solvent front? So solvent front, that topmost line, what is that line? If you have been asked define solvent front, what is solvent front? So this simply means the farthest point a separated pigment can reach. So that farthest point in a chromatogram that a separated pigment can reach is one which is called the solvent front. Then the next question is what you can see we have already indicated. Indicate its position in the diagram. So That is it, we have already indicated. So that topmost line is always called the solvent front, the farthest point a separated pigment can reach. And what about the baseline? So the baseline is that line now where the pigments to be separated are placed. So if you have been asked to define the baseline, you're going to say that this is the region whereby the pigments to be separated are placed. That is now what is called the baseline. Question number C is asking, which chromatogram were present in dye E? So which of the chromatogram were present, which of the chromatograms was present in dye E? I wish they could have said which pigment, because the correct term to use is which pigment. So which pigments were present in dye labeled E? So as you can see, we have D, yes. Why D? Because you can see the pigment of D, the pigment of D is exactly on the same line with the pigment of E, which is blue. And then the other pigment is A. You can see pigment of A is exactly direct line with the yellow of pigment E. So that's why the answer we gave was D and E, because they are on the same line. So since they are on the same line, it means that these chemicals are exactly similar. It means that these colors are exactly similar. So that's why we gave our answer as A and D. So letter D is asking which dye is pure. So the pure dye here is dye letter C is pure. Yeah, the pure dye here is dye letter C. Why? Because as you can see, this letter C, it does not coincide with any other pigment in the chromatogram. So the answer is letter C. Also, we can give letter B, because B did not even separate. But since B did not separate, that is not a dye. The best answer to give is C, because C did not coincide. You can see its pigment. It is only alone. It does not coincide with anything on the same line. So the best answer is letter C, because it did not separate. So letter E is asking which dye is insoluble. So the dye that is insoluble is the dye that even has not begun to move. It has not moved even a single bit. So here the answer is letter B. So letter B is the dye which is insoluble. Why? Because it, as you can see in the chromatogram, it moved the shortest distance. So the answer is letter B. So which dye is most soluble? So the dye is letter C is the most soluble. Why? Because it has moved the farthest distance. So the pigment always in this chromatogram or any other chromatogram, so the pigment that will have moved the farthest distance, that is always the most soluble. So maybe, for example, if we had another one that moved on the solvent front side, on the top side, that is what we could have said. But now since we have C which has moved the farthest distance up, so that is the one which is the most soluble. So now the next question, I think this might be the last one. The question is asking, the table below shows some properties of chlorine, bromine, and iodine. So these ones are they are group 7 elements: chlorine, bromine, and so remember it begins with fluorine, then chlorine, then after that you have bromine, then after that finally we have iodine. So complete the table below. So as you can see, we have already indicated the table. So chlorine, the color of chlorine is a pale green gas. So chlorine, that Roman 1 is pale green, because chlorine, as you can see, chlorine is always a pale green gas. So bromine, we are being told to answer solubility in water. So bromine solubility in water, bromine is always slightly soluble in water. It is liquid bromine. Bromine is a liquid. It is slightly soluble in water. Then finally, iodine, we have to answer the color and the state. So iodine is a purple solid. Yeah, so iodine is purple solid. That is the iodine which has not been dissolved in water. It is a purple solid. Question B is asking, chlorine gas is prepared by reacting concentrated hydrochloric acid with manganese 4 oxide or potassium permanganate. So as you can see, so chlorine is prepared by reacting concentrated hydrochloric acid, not dilute. Concentrated hydrochloric acid with manganese 4 oxide and or potassium permanganate. Write an equation between hydrochloric acid and manganese 4 oxide. So remember, we are dealing with concentrated hydrochloric acid. So if manganese oxide reacts with hydrochloric acid, you're going to get manganese 2 chloride. Apart from that, you're going to get chlorine gas, and then you're also going to get water molecules. The state symbols are very important, as you can see. So that is the formula, that is the equation that you're going to get in this case. So you're going to get chlorine gas, whereby you have been told that you can prepare chlorine gas by doing this method.